This setup is for processing spodumene ore to recover lithium. It is a flotation separation plant and has a high recovery ratio for LiO2. For spodumene ore, the lithium concentrate, LiO2, grade can reach about 6 to 7% after processing. The full processing plant includes 5 systems: a crushing system, grinding system, flotation system, concentrate filtering system, and tailing recovery system. Main machines include raw material feeding hopper, vibration feeder, jaw crusher, cone crusher, vibration screen, belt conveyor, small vibration feeder, storage bin, ball mill, spiral classifier, mixing tank, flotation machine, slurry pump, thickener, disc vacuum filter machine, filter press, etc. Crushing system. A vibration feeder is for feeding raw material below 300 to 400 mm to the primary jaw crusher stably and evenly. There are 2-stage crushers in the crushing system, including a jaw crusher cone crusher. The jaw crusher is for the primary crushing of big stones below about 100 mm. Then output from the jaw crusher will go to the cone crusher for secondary crushing. The output from the cone crusher is about below 30 mm. Then the output from the cone crusher will go to the vibration screen. Screen out 0 to 30 mm and amp, more than 30 mm over size, and send it back to the cone crusher for crushing again. The 0 to 30 mm will go to a ground bin by conveyor, so the crushing system can work separately from the grinding system. Grinding system. Since the 0 to 30 mm material is stocked on the ground, I need to feed it to the storage bin before the ball mill, then feed the material smoothly by the electromagnetic feeder to the ball mill through a belt conveyor. The ball mill is for grinding material to small fine powder, to make sure to liberate LiO2 as much as possible out from spodumene ore, so the next flotation separation can get the best recovery ratio. For spodumene ore, usually, the final product of 200 mesh occupies 75 to 80%, so in order to get those fine powder sizes, the ball mill needs to work together with a spiral classifier. Overflow of the classifier will be the 200 mesh fine slurry, and the underflow coarse particles will go back to the ball mill grind again, to be closed circuit. So from this grinding system we'll get 200 mesh slurry. Flotation system. The 200 mesh slurry will be firstly sent to the mixing tanks by slurry pump, to make sure the material is mixed completely with chemicals. Then material from the mixing tank goes to flotation machines. At the same time, I need to add relevant chemicals in the flotation machine to separate out LiO2. The flotation process has primary separation to get concentrated ore and tailings. The concentrated ore will be processed by another 2 stages of flotation, and tailings also will be processed by another 2 stages of the flotation process. In this way, can increase the LiO2 recovery ratio and make the LiO2 grade as high as possible. So after the flotation process, I will finally get high-grade LiO2. The flotation system can be adjustable according to material real conditions. Concentrate ore filtering system. After getting the LiO2 to concentrate ore from the flotation system, it is with water, so it needs to dewater. Because the size is very small, fine 200 mesh, so firstly use a thickener to thicken the concentrate, make higher density, then use a disc vacuum filter machine to filter water and dry lithium concentrate ore. Tailing recovery system. After processing in the flotation system, the tailings will flow to a tailing tank and be pumped to a thickener for precipitation. The underflow is concentrated higher density tailing, which can be sent to filter press machines to filter water, finally get dry tailing and can be transported away. The water from the thickener and vacuum filter can be reused to process plants. This spodumene ore flotation processing plant is highly effective to recover lithium, LiO2. The plant design can be customized as per rock minerals conditions and capacity customer requirements.